Okay, hello. We are here at Mucha AI. I'm here with Rasa, Tara, and Het. And today we're talking about OpenClaw. So for those of you who don't know OpenClaw is, I would tell you what OpenClaw is. And it became a viral vibe coded AI assistant. But I've seen so many videos talking about how to use OpenClaw, how to install it, how to integrate it. But I have not seen many videos talking about how it works. How is it designed? How it works? So today we're going to do a deep dive into how OpenClaw actually works behind the scenes. And this was done by Rasa. He's doing a deep research into the architecture of OpenClaw, and he designed the graphs to explain it. But before going there, I just want to give you a story of OpenClaw, how it became. So, as I said, it's a viral open source personal AI assistant, and it's creates a framework for autonomous agents. And it was originally designed to perform real world tasks, such as like opening a calendar, sending emails. And what made it different was that it was built to act, to do things. So that's what makes an agent different from a chat bot or chat GPT. It can browse the web, it can manage the files, it can interact with their messages, and so on. But what is and it was designed to run locally on a personal computer, and it was originally created by Peter Steinberger. He's an Austrian engineer, and then he started in November 2025. And he at that time he was frustrated with AI chatbots, were purely passive, and he built a 1 hour prototype original on WhatsApp relay. So it was just a thing that would do things on WhatsApp messages. And then he vibe coded it. Basically, the code was written by AI generated majority of the code. And he was just telling how he expects it to work. And it worked. But it became very famous. And there's this interesting story. So the OpenClaw's fame was a mix of high stakes legal drama and some kind of magic that happened. So there was some chaos about the naming. Originally, it was called Clawbot, and so it was based on Claude mostly. So they call it Claw, okay, Claw. And then there was some trademark complaints from Anthropic, and they changed the name to Moltbot. And then again, before settling on OpenClaw, so 3 days later, and then they branded it with Lobster and throughout the site. And there was a $4,200 car discount story. So the project went mainstream in early 2026 when developer AJ Stuyvenberg shared how his OpenClaw agent independently contacted multiple car dealerships, pitted them against each other in a bidding war, and negotiated a $4,200 discount on a new SUV while he was at work. So that story became viral, and it became very fast growing repository on GitHub, fastest growing on GitHub history. It got 250,000 stars and even higher than React in popularity by March 2026. And right now, by spring of 2026, I was acquisitioned by OpenAI on February 14, and Sam Altman announced that Peter Steinberger was joining OpenAI to lead a personal agent. And then there was a global craze and seen massive adoption in China. It's called raising a lobster, where users use it to bypass traditional app interfaces and manage everything through messaging apps like WeChat and WhatsApp. And that's a strong point of it. And then there's like security issues that was brought up. And then the current development is heavily focused on safety. And there's something called Claw Havoc incidents in some major vulnerabilities were detected. We also have Nemo Claw, which was announced by NVIDIA, which is another version of OpenClaw, and we will talk about that as well. So stay tuned. I pass it to, this is kind of a long introduction, but it was a fun story. So I wanted to everyone to know what basically OpenClaw is. And this is a wonder. I always wondered why this has become so popular. There was a recent interview. I will share that interview with you as well on one of the major podcasts. But still, very few information about how the architecture was designed and how it works. So without further ado, I pass it to Rasa to talk about the OpenClaw architecture.
Yeah. So I'm Rasa. I've been wondering the same thing. Like, there's a lot of videos regarding OpenClaw, and like they sort of explain like, oh, this is how OpenClaw works, but all they really show is how to use OpenClaw, which is like an entirely different thing from how it actually works. So I actually tried to look into like its actual repository, its documentation, and tried to sort of decrypt exactly what it does. So this is Figma, and I tried to make a little bit of a diagram so that it's easier to understand what I'm trying to explain. But mainly how it all starts, you basically ping the brain. So like the brain of OpenClaw is like this gateway. So this is a background daemon service, and ideally it runs 24/7. So it's OpenClaw itself, and it will just run in the background and always be online, and you can always talk to it.
Sorry,
And
a
so
question. Is this like a fast API backend system? Is it like a backend server that runs locally?
it's a daemon service. I don't know what
Daemon.
a daemon service is, but
Okay. Background
yeah.
daemon. Okay. Yep.
Yeah. And so like there's a bunch of ways you can sort of ping it. These are like all these webhooks. So like Slack, Discord, Telegram, WhatsApp, WeChat. There's a bunch of things, and then you can ping it. And then what'll happen from there is there's sort of an agent manager. So OpenClaw has like a list of agents. You can like define them to do different things. You can make like an assistant agent. You can make like a work assistant agent. You can make like a calendar agent. And so there's an agent manager. And every time you make a call to the agent to tell it to do something, it'll go through this agent inference loop. So how the agent inference loop works. So this is not particularly new, or it's not the novelty of OpenClaw, but the agent inference loop is how it sort of does multiple processes at once. So like some example might be to something basic. You want it to fix your tests. Maybe you're running code and you want to fix your tests. And so you make a call to the LLM provider, and then it will analyze its skills. So skills is sort of, they're basically like plugins to the LLM, and it basically gives it instructions for its tools. So like an LLM has a number of tools. It has maybe like a code editing tool, or like a calendar tool, or like a command line tool. And so the skills will tell it how to use it. And then in this workflow, there will be sort of a tool to basically like edit your code. So there's a skill, it'll tell it how to use the edit code tool. And then the tool will go back into the gateway or the brain, and it will execute the tool. And then after the tool is executed, then like the code is edited, and then it'll get back the output and it'll go back to the LLM. And then from there, the agent manager will determine if, the prompt has been finished or it needs to keep going. So it'll do another round basically. Mm-hmm. And then the next round, maybe, okay, now it wants to run the tests to make sure that its code edits actually fixed what it was trying to fix. Mm-hmm. And so it'll run the tests. So it'll call the tool. Maybe this tool is like the command line tool. So it'll go through the loop again. It'll tell it to call the command line, and then it'll go to tool execution. and then it'll call the command line to run the tests. And then if the tests all pass, then the LLM will get that. It will understand the output that all the tests have passed, and then it'll go back out, it'll exit this loop, and then back to where you message it from to pretty much tell you, oh, the tests are good and working, and your code changes have been committed. So that's like a general workflow.
Okay, so like here, I need to let's focus on the inference loop itself. It's basically designed to be a general purpose kind of inference loop, right? So
yeah,
how about the other like fixed prompts or fixed part of the prompt engineering that keeps the loop organized and running? Like, is there something hard coded into the inference loop that is specific to OpenClaw?
I don't think it's hard coded. It's managed by an LLM, and that LLM will, it almost has like a mental list of tasks, and if it's managed to complete all of those tasks, then it determines that the loop is done.
And then another question I have about the loops in general is that each time you iterate, do you give the history of what happened to LLM, or you start as a fresh kind of approach? Like let's say I want to do task A. The first iteration goes to LLM, doesn't pass. Now I want to do the second iteration. Do I tell the LLM that the previous one failed, or do I start as a fresh loop?
Yeah, I mean, you have to tell it that the previous one failed, or else it'll
it
just
would
do the same
repeat.
thing.
It might repeat the same thing. Okay. Yeah. So as this goes on, I imagine the context gets more and more filled up, right?
Yeah, so like this is a pretty token consuming process, and like sometimes the agent can end up in this negative feedback loop where it just keeps on going and going.
So
Ideally, you don't want that to happen.
So that's always the danger, that it goes on a loop and keeps increasing the token consumption, but increasing the window of tokens, and it doesn't get out, right?
Yeah,
Okay.
that is a major concern.
Okay. Yeah, please continue. So there is like event interactions also on top of that.
Yeah,
Let's talk about what happens with the event emitters and other parts, like
yeah.
especially.
So OpenClaw actually designed their product to be able to have plugins added to it. So like they wanted to make it not as sort of like a standalone, but like other people can contribute to it, and people can add their own plugins and like give it its own external memory or like external services. So they have a bunch of event emitters. So like at various points in this inference loop, like maybe 20 times each loop, it'll output a certain event. So like there's an event before a specific tool call, and then they'll emit event after a specific tool call, and they'll like emit event before a prompt or like after a prompt. So they have a number of checkpoints, and at each checkpoint, it'll emit event for a plugin to do its thing. So like maybe a plugin provides some extra functionality. So like one functionality that we're actually working on and people have put in is sort of an external memory service. So like before a prompt is made, it'll go through the plugin event emitter, and then it'll make an external API call to like this external memory service, and then the plugin can run its thing while this inference loop is actually going on.
Okay. So the way I understood it was that the plugin event emitter is some kind of logging system as well for it. But from the original design, it doesn't go anywhere. It just gives you ability to save it somewhere if you want to. But if you don't save it, it doesn't do it on its own.
Yeah. Just like a way to exit the loop or like do things while the loop is going on.
And the steering, it's green again, so which is the same color that you had for the human interface.
Yeah.
And I assume it means that you can interfere, like if you see something's going wrong or the loop is going off, so the human can enter here and change things, like, or stop it,
Yeah.
do something, right?
Yeah. So like a human can actually enter the loop, or because like you can't, I guess, interrupt the LLM while it's like running, but how they have it work is that after a single loop is finished, after it's like done a tool call, it has to go back to the LLM, and that's kind of the opportunity for human intervention. And that's where steering will take place. Like maybe it goes on an infinite loop, and then you kind of realize that, and so you wanted to tell it to stop.
Or
And
do
so
things differently, or you see that
yeah,
you got this wrong, please correct this, or
yeah,
that's
like
what
you
the
do.
place you can enter, basically.
Yeah, like you have intermediate output, so you'll be able to kind of keep track of along of what's going on inside this loop, and then you can interject whenever you want.
Very cool.
Yeah.
So yeah, now let's move on to the memory side of things.
Yeah. So the idea, because it's like a 24/7 long running agent, if you treat it just as like a normal LLM chat, the context would just it would last a few hours, and then you would hit the limit. So they have an internal memory system. So they actually have a few things going on. So this is like something unique to OpenClaw, their whole NDs. So this is a number of ND files which are sort of used to determine various preferences of the bot and the user. So like there's user MD, which is a MD file to sort of give details about how the user is, like preferences for the user. And then there's like identity, which is sort of the identity of the OpenClaw agent itself. So like to give it a personality instead of just having a basic LLM personality. But the reality is that this is just like extra prompts. So at each pass, it'll inject all this preference information into each LLM call, so that all the time it's going to have all the preferences known and all the user preferences known, and like it'll act a certain way.
So it means that every call to LLM includes the content of these files:
Yeah,
agent information, soul, tools, identity, user, heartbeat, memory. And heartbeat is something a bit more innovative that belongs to OpenClaw, and it's for running things that need consistency in time, like operations that need to be repeated every 3 hours or every 6 hours or every certain amount of time. It's just a reminder that keep checking this, keep researching, so keep updating something. Those go to the heartbeat, right?
yeah. So it's like, then there's like the actual memory system itself. So how it keeps the chat small enough to keep functioning. So how it works is you have your active chat itself, and this will always be passed, but there's a mechanism to effectively truncate it when it gets too large. So when it's like the token size is too large, then it'll have a memory flush operation, and then it'll push it into another ND file, which is the daily logs. And then the daily logs is sort of more of a human interactable interface. You can open the MD file and actually look at what you were talking to on the agent on this specific day. And then from those daily logs, they'll push that information into an actual database. So this database is unique to each agent. So each agent will have its own database and its own unique conversation history to reference from. And then this database itself is a tool call. So during the tool call inference loop, if the agent determines that it needs to recall something from a long time ago, like a month ago, it'll realize that information is not going to be in the active chat. And so it'll make a tool call to get information from the database. And then it has the necessary information to keep on going. So that's pretty much how the memory works.
So a question. So with the memory, the default memory of OpenClaw, everything gets saved on the hard drive of the computer when it is that
Yeah.
right? Because that's why it's persistent, but that's also limited to the size of the device that's being used.
Yeah. Yeah.
Yeah.
The daily logs are just simple files. They reside on the local, and SQLite is also hosted on the local computer and works as a long-term memory. And the last video we talked that SQLite, and during the tool call, when there's a search to the long-term memory, it uses a combination of keyword search with 30% weight and semantic search with 70% weight. But it doesn't use it on a regular basis. It's just there in case that
Yeah.
agent decides it needs additional info. Yeah, that's all.
Yeah. And this is pretty much the general framework. And
And
there's
even the daily logs are not detailed logs of everything happened. They're just summary, like short summaries of everything happened during that day.
Okay, but they can be pulled whenever it's needed.
I think it also has session summaries, which are more detailed. But daily logs go into long term.
yeah. But yeah, this
It's
is pretty much the general architecture. And then there's also like external tools. So like they have the ability to connect to external devices. And so like it can even make like phone calls for you, or like it can look through your camera lens to see what your camera sees. Yeah, there's a lot of integrations regarding OpenClaw, and that's how it's able to accomplish so much because of like the sheer amount of tools it has at its disposal.
Cool. So for this viral application, that the car dealership that you mentioned, Majid, it's probably use the same like for the memory.
For example, I don't know exactly how he designed it, but exactly for example, it could have a search tool that goes online, looks for car dealerships. Okay. And then it has another tool to pull out like the prices. And then tells them I'm look for this specific SUV model. And then sort out the prices and send emails to those dealers telling them that I have another dealer that's giving me a lower price and here's the link and so on. And it just goes on loops and does one thing after another, like does the search and comes back, does the sorting, and then sends emails and waits for the response or something like that.
Yeah, apparently at the end when it got the discount, it wasn't able to make the payment. So there was some sort of human intervention was needed.
Yeah. Now people are using it for more personal work, and I think it's automating something. The use cases that I've heard of is more geared towards like sales, customer support, or like prospecting, things like that, mostly. Very good. Het, do you have any questions? You're on mute.
Oh, sorry. Yeah, good so far, I think. Yeah.
Okay, good.
Okay.
So let's now move on. NemoClaw.
Yeah. So NemoClaw kind of spurred about because of OpenClaw's, I guess, lack of security. Like you can kind of tell based off its design that it has access to like all your files. It can access.
Sorry, just a second. Het, there is a feedback again. Okay, yeah.
Yeah. Okay.
Right.
Yeah. So like it has almost like too much access to your computer, and if it was like a malicious AI bot, then it could like completely ruin your host operating system.
Yeah,
so
like
you can do that by
could
accident.
message on WhatsApp and tell the agent to delete everything or give me a copy of all the information on this computer, and it would do it, right?
Yeah.
Things like that.
So
Oh, right. Yeah. And the other side, like the open, like just with the OpenClaw, I was thinking if you want to remove everything, right? Like remove OpenClaw and you're done with it. You're moving on to next project. How difficult would that been? Because like you need to remove probably manually all the APIs and from the memory because it sticks to your computer. Is that something that, because it's a physical, I was thinking like how easy it is to, once you have it installed and you have it on your machine, to get rid of it, or just like, especially if you're doing it for work, you just want to do it for one project and then you're done with it and you want to get rid of it because it's backing up all of your APIs and files and events somewhere. You probably need to like,
yeah, because it has access to who knows what changes it made to your laptop or Mac.
right.
But yeah, so that's the idea of like, instead of it running on your host, it runs in a container. So like that's NemoClaw. So they have an open shell container, and then it'll lock it to this little box. So, and then there are like strict firewall securities that will prevent it from making API calls outside of this box. So you have to deliberately, punch a hole open. So like give it access, or like allow a certain API call to be made, and then it can actually leave this little box. But how NemoClaw works, so what it does is like another feature. What they wanted to do as well is have it so that not only that it can't make random API calls, but for the API calls that it is approved for, it shouldn't have access to your API key. So like for security purposes, you don't want OpenClaw to have access to the API key, because then it can like make calls whenever and things can get dangerous. So the idea behind NemoClaw is to have these API keys that are sitting outside of this box, and a lot of the design is managed so that it can actually still make the API calls without actually having the API keys at hand. So how that actually works is NemoClaw is basically its own little plugin. So they have OpenClaw as an image. They'll run this image in its own container, and then NemoClaw is a plugin. And what it'll do, the plugin event emitter will allow it so that this plugin can run whenever. And what it'll do is it'll supply a proxy. So it'll tell OpenClaw, that this is an LLM, or it'll give an endpoint. It'll give like an open shell endpoint, and it'll tell them to contact this LLM when you want to do inference, and it'll go through that proxy. So it'll make an LLM call, and it'll think it's calling the actual LLM, but it's actually calling the proxy, which sort of lives at the boundary of OpenShell. And then this proxy will actually fetch your API key from your host. And then its only job is to inject this API key into your API request. And then it'll make the call to the LLM, and it'll feed back the information to OpenClaw. So because of this proxy simply has the job of injecting the API key. And so with that method, OpenClaw does not need the API key to make the calls that it needs. And that's what gives it really the security.
Okay, very good. So in a nutshell, the way I understood it was that basically it's putting OpenClaw on a sandbox, right? Running it on a sandbox and controlling all the input, output, and authentications through the NemoClaw. But what is the NemoClaw plugin itself? What is the role of that blue box?
So this isn't actually doing a whole lot. So the plugin is simply telling OpenClaw to use the proxy instead of the actual endpoint itself. And it tells it to use it as a default. And that's it.
Okay,
So
just reroutes the access to the... Okay.
Yeah, that's all it does.
But I think it doesn't solve all the issues that we thought about. Yeah, Het has a question.
Okay, so when you say like it restricts the API calls to the external application, so does that means like only LLM calls, or what if I want to connect any other external tool, like any other external application which acts and OpenClaw can make different calls to make that external application works?
Yeah, you can make external application calls. It's just the difference between OpenShell is that you have to explicitly allow it. So there's like there's a policy file in there, and you can sort of make a list of allowable endpoints. And then if it's in that list of allowable endpoints, then it can make a call outside.
Mhm.
And so that's what gives it the security, but also still the ability to use external resources.
Very cool. Okay, we only have 4 or 5 minutes left, and we want to touch upon the next step as well. So now we're revealing the secret that we are working on a project called NemoClaw, and it's using the backend for long-term memory, which is a lot more robust and powerful. And you have some related plans here. So let's talk about Memento plugin and how it would integrate. Yeah.
Yeah. So with like the idea of using external services in mind, so we have sort of an external service that's Morche and Memento. So we want to use Morche's information theoretic semantic search in order to supply OpenClaw's external memory. So what we do is that we have sort of a plugin event emitter, and then this Memento plugin will basically allow it to, so we make a specific API call, we allow that through the OpenShell, and then we can make external API calls to this Morche endpoint. So that's how it'll break through this, and then it'll call our local Memento server and change, and then it'll go straight to Morche.
Yeah.
And the other perk is that because Morche also has native LLMs that you can call, you can use those instead of using a different API key to call like Anthropic or OpenAI. So like you can almost remove this entire section.
Yeah. Yeah.
Mhm.
And then you can solely rely on Morche to make your LLM calls for you, and then also handle your memory for you. So this API key is supplying both the LLM calls and the remembering operations for external memory.
And Memento also has this built-in functionality to work as an agent, as a co-agent with it, and not just be a passive memory, but be part of the operation and interject whenever needed. So that green steering, basically a steering functionality, Memento actually can be actively like suggesting things from the memory or from the past experience and help with the steering as well. That's just a thought I had.
Mhm.
Yeah.
Yeah. And also like enhancing like for the OpenClaw users, right? They're probably looking for something that is more deterministic. And with Memento, because it's based on Mocha's platform, it's not following HNSW, and it's not approximate.
Yeah, that's another advantage. So we will talk about Memento in detail later on. We had the first version called Mumla, and we did some experiments, and it's a very interesting function, a very interesting project. We'll talk about that more. But today it was just to understand how OpenClaw works and how we can, and how it enhances it, and how we can actually add a more robust memory to it. So thank you very much, Rasa. Is there anything else you guys want to add?
I pretty much talked about everything.
Okay, very
Thank you.
good.
Yeah.
Thank you very much. See you next time. Bye.
Yeah.
Bye.
Bye.
Bye.